Okay. When C is less than 0, it's a vertical translation of absolute value C, because if it is 3 down, it's 3 down, right? It's going to be down. Okay. The vertex of the graph f of x is equal to ax squared plus c is 0, c. And let's go back and look at the graph. Tell me, what is the axis of symmetry?
0.
Axis,
X equals 0.
axis of symmetry? It's
X
still
is
that.
equal to
Correct.
0.
Yeah, that's correct. You're right. X is equal to 0. Nothing to do with the C, because C is our y coordinate. Axis of symmetry is a vertical line, so it has to look like x is equal to the x coordinate of the vertex. So far clear?
Yeah.
Let's do some examples. Example number 1 for you guys. Okay. Again, we are going to do the same process as we did earlier, because these are just the beginning problems of all the graphing of quadratic equations. I want you guys to do the table of values. As we move on to other lessons in chapter 8, we will learn other techniques of graphing, but until then, let's make the table of values. Okay, so we're going to find the y values. It's going to be -2 squared plus 2, which is 6. Okay, go ahead, find the rest of the values. When it is -1, it's going to be
3.
When it is 0, it is
2.
2. When it is 1, it's going to be
3.
correct, and 2.
6.
That's correct. Now plot the points. -2 corresponds to 6. Okay, let me take a different color. Purple. Okay. And -1 is 3. 0 is 2. Then it's here, and it's here, and then a nice. That's our graph. Okay. Do you see that the vertex is moved up 2 units?
Yes.
That's because of this +2 right there. All right. Okay. Try B. Question B is y is equal to, oh, no. We have to do one more thing, guys. It says compared to the parent function y is equal to x squared. How would you compare?
Shift by 2 units.
Correct. You can say that it's a vertical translation or vertical shift. A vertical shift 2 units up. That's how you would compare it with the parent function. Okay. Moving on to the next example, B, y is equal to x squared minus 1. Let me just erase that. Y. Okay. Make a table of values. Use the same x values, -2, -1, 0, 1, and 2. Okay. All right, guys. So for the second function, it's x squared minus 1, x squared minus 1. It's going to be -2 quantity squared minus 1. That's going to be? That's going to be 3. Okay, correct. And -1, it's going to be?
0.
That's correct. And 0, it's going to be
-1.
and 1 is
0.
when it is 1, it is 0. That's correct. And 2 is equal to
3.
3.
3. Let's plot the points. -2 corresponds to 1 second. Okay, -2 corresponds to 1, 2, 1, 2, 3. And the -1 is 0. A 0 is -1 here and there. Now listen, your graph should look like a U, okay, not like a V. So do not use straight lines or anything to connect the dots. It should be a curve, a smooth curve. All right, what is the vertex of this graph? This is the vertex, which is
0, -1.
0, -1. That's correct. What is the axis of symmetry?
0.
X is equal to 0.
Or yeah.
Yeah, so the axis of symmetry is x is equal to 0 because it's a line. This is the vertex and that's the graph. Okay, how would you compare it with the parent function? What kind of translation is happening?
Vertical shift.
Vertical shift
1 unit down.
Vertical shift 1 unit down. That's correct. Okay, why don't you guys try C? Okay, you guys try C. I'm going to use the same X values, -2, -1, 0, 1, and 2. Find out the Y values. Okay, so the values that you guys have is, tell me the first value, please.
3.
3, and then
-3.
-3, and then
-5.
correct, -3 and +3. You see that the values are repeating because of the symmetric property. It just goes back. Okay, plot the points. -2 corresponds to 1, 2, and 3. Okay. -1 is negative. -2 corresponds to 3. -1 corresponds to -3. 0 corresponds to okay, so that's the graph. A nice U-shaped graph. Oops. Okay. 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 Now, look at this graph. What difference does it make because of this 2 here in front of it? If you just think about the shape and the size, so let's think about the size. In the first example, we did not have any number in front of x squared. It was just the 1, but now we have a 2.
Vertical stretch?
Yeah, that's a vertical stretch. Do you see that the graph has become a little closer to the y, like a little stretched upwards, like a narrow one?
Yeah.
That's because of the 2 in front of it. And also it has moved down 5 units because of this negative 5 units down. And this 2 will make the graph like narrow. Is it all clear? Okay, so now you guys write down the transformation. The transformation here is going to be when you compare with the original function, which is the parent function. You're going to say, number 1, there is a vertical. Is that a stretch or shrink?
Stretch.
Stretch by a factor of 2. And also, there is a vertical shift down by 5. So the graph became like the graph became like much more narrower because of the 2. It also moved down 5. Can you tell me the vertex?
0, -5.
0, -5. That's correct. Axis of symmetry, it's still x is equal to 0. It didn't affect the axis of symmetry, but it did affect the vertex. Okay, why don't you guys try D on your own? Okay, so the table of values are x, y, -2, -1, 0, 1, and 2. It's going to be, what's the y value for -2? Is that -5?
Yeah.
Okay, then we have 1, 3, 1, and -5. Okay, now plot the points and tell me the transformations. The transformations would be, oh yeah, did you guys see that the graph flipped?
Yeah.
Why?
There's a negative.
Correct. Okay, so this is what we are going to do. There are 3 transformations in this problem because it's actually flipped.
Okay.
And then there is
Vertical stretch.
then there is a 2 in front of it, and then there's 3. So we are talking 3 different sections. So first, let's say the graph is vertical stretch. I'm going to write VS. Do you understand what that is? Okay, vertical stretch. Oh, or I'm going to write stretch because it could be shrink also. Vertical stretch by 2.
And then reflection over x-axis.
Very good. Then reflection over the x-axis, and then a vertical shift down by 3.
Isn't it up? Oh wait, no, never mind.
Oh no, it is down. It's down. I'm sorry. Yeah. 1 second. It is up, not down. Oops. Okay. A reflection across the x-axis. Vertical shift up by 3. So -2, let me graph it. -2 is -5. Say here. -1 is 1. 0 is 3 here. And then here. So the graph is going to be. Okay, is it clear?
Mm-hmm.
Okay, let's get into that word problem. Just read it. So we have a function h of t is -4.9 t squared plus s of the s0, which represents the approximate height in meters of a falling object t seconds. You see that t seconds after it is dropped from an initial height s0. So this s0 is the initial height, right?
Mm-hmm.
And then this ht is the height of the ball after t seconds, or whatever that is. Falling object. Okay. If a coin is dropped from an initial height of 44.1 meters, which means this is your S0, is 44.1 meters. The first question is, after how many seconds does the coin hit the ground? Okay. When the coin hits the ground, the height must be 0. Because this h of t is the height of the falling object after t seconds. And this one says after how many seconds, that means we are asked to find t. Does the coin hits the ground means the height will be 0. Okay, so h of t, and then you replace the h of t by the equation, which is -4.9 t squared plus s0 in this problem is 44.1, because the initial height is 44.1 meters in this problem, and you set that equation equal to 0. And we are going to find time. That means we have to solve the t. How do we solve the t? We need to get the t all by itself. But there is t squared, but which is okay. Let's keep the t squared by itself first. You're going to subtract the 44.1 from both sides. So you have -4.9 t squared is equal to -44.1. Okay. Guys, since I don't have enough space here, I'm just going to go to the new page right here, okay. H of t is equal to -4.9 t squared. We subtract both sides. And to get the t squared all by itself, we are going to divide both sides by 4.9. So they get cancelled. You have t squared all by itself.
That's
Okay.
9.
Is that 9?
Yes.
Okay, so this, if you want to do it in the calculator, that's fine. Negative and negative becomes positive and you get 9. So t is equal to square root of 9, which is plus or minus 3. You guys know that it's plus or minus 3. But in this particular problem, because it's a real life problem and it's a t is a time, can you include -3 as an answer?
No.
No. So you would say just +3 in, was it in seconds?
Mm-hmm.
Yeah.
Okay. Okay, that's correct. Okay, seconds. Okay, seconds. So the answer to this question is the coin will hit the ground after 3 seconds. Do you guys get this?
Mm-hmm.
Okay. Now, think about part B. If the initial height is m meters lower, how will this affect part A?
It would take less time to hit the ground, right?
Yeah. Can you guys find the time in that case also? But then this says m. So, oh, you can just answer like that too. That's fine because you cannot find the answer because it will be in terms of m.
Yeah.
Yeah. So what would you say? Let me just check what type of answer the book needs for that. It will definitely take less time, but then let me see if they are looking for an answer in terms of m. Okay, 2. Okay, so this is what it means. Yeah, this is the answer that the book is expecting. So you guys are going to say that if, okay, I'm going to go to the new page, okay? If m is greater than 0, it doesn't say m is positive or negative. Does it say that? No,
No.
right? It just says that suppose the initial height is m meters lower, right? So let's say if m is greater than 0, that means it's lower. It's like if m is greater than 0, what will happen to the graph, guys?
Huh?
If m is greater than 0, so I think I have to go back to the question. So I don't remember. Okay. Suppose the initial height is m meters lower. So it's going to be 44.1 minus m, correct?
Mm-hmm.
Okay. And if m is greater than 0, which means a positive number. Tell me a positive number.
1.
1.
1, right? Then what will be the initial height then?
40.1. I mean 43.1.
If m is greater than 0, let's say it's 1, then the initial height is going to be 44.1 minus 1, which is?
43.1.
Okay, in that case, what do you think the time will be? Will it take more time or less time?
Less time.
Okay, you're right, less time. Less than 3 seconds. You can say less than 3 seconds because we already found the 3 seconds before. Less time, which means less than 3 seconds. Okay, now how about if your m is less than 0? Give me a number that's less than 0.
-1.
-1.
Okay, -1. If m is, okay. If m is less than -1, your initial height is going to be 44 minus 1 minus -1.
So that would take more time, right?
Yeah, because then it's 44.1 plus 1, which is definitely more time. So you can say that this is going to take more time because now our initial height more than 44.1, which is 45.1. So you can say this will take greater than 3 seconds. Is that clear?
Mm-hmm.
Okay, I think I'm going to write this on the other page because for people who are not here today, if m is less than 0, let's say, you guys try the next problem then. Let's say m is equal to 1. Then the initial height is going to be 43.1. So it will take less than 3 seconds. if m is less than 0, let's say m is equal to -1, then initial height is equal to 44 minus -1, which is, so the coin will take more than to hit the ground. Is that problem clear?
Mhm.
Okay, all right. Then we have one more example.
I'm using it. No, but it's not. You got me I don't know where it is. Right there. You couldn't get up. Thanks.
Okay. So after how many seconds, that means f of t is going to be 0, which means -16t squared, plus s0, which is -16t squared. S0 is 36, is equal to 0. You subtract 36 from both sides, so you'll get -16t squared. Divide by -16 on both sides. What is -36 divided by -16?
2.25, I think.
2.25.
E over
So t is equal to square root of 2.25, which is
1.5.
seconds. That's correct. 1.5 seconds. So the answer to the first part is it will take 1 point. Okay. Suppose the initial height is k feet higher. This time, if it's k feet higher, if initial height is 36 plus k. Also, we have to consider two cases here also. What about if k is greater than 0? Which means, let's say 1. Will it take more time or less time? When k is 1, your initial height is going to be 36. It was 36. Now, if it is k feet higher, it is going to be 36 plus k. Do you think it will take more than 1.5 seconds or less than 1.5 seconds?
More.
More. You can say it will take more than 1.5 seconds. To hit the ground. Okay. Now the next thing is, if k is less than 0, let's say -1, S0 will be 36 minus 1, which is 35. So what do you think it will take?
Less.
Less time. So marble will take okay. That's what it is. Are there any questions from today's lesson?
No.
No.
Okay, and let's talk a little bit about the homework. Did you guys have any homework that's due today? No. Yes.
Yeah.
Yes. Was that a review from the chapter 7?
No, it was 8.1.
Was it 8 point?
No.
No.
Chapter review.
Yeah, it was a chapter review, right?
Yeah.
Yeah.
Okay. I didn't upload the answer to this my iPad, so that I cannot show you guys now. But can you guys do me a favor from now onwards? If you guys have any questions that you want to see, we'll probably don't have enough time to go over every question and show like how we do it in class. Maybe I can think about showing you guys everything.
Mhm.
But you need to let me know ahead of time which questions you would like to work with me, or which questions do you like to see the work for.
Miss Mohandas.
Yeah.
So how are we gonna turn in? Are we just gonna turn in the homework? Like, are you gonna put it on Google Classroom and we can turn it in there?
Yeah, I'll figure that out before Monday.
Okay.
Until then, hold on to it. Please do it on a daily basis. Do not just keep it for last minute. I will. I didn't get time yesterday, and I didn't get time today also. So I'm gonna do that sometime tomorrow,
Okay.
and figure it out.
Wait,
So
Mohandas,
yeah.
when is the do you know when the actual schedule is coming? Like, you know when like all the teachers are gonna do like the
Mm-hmm.
because one of my other teachers said that they were gonna make like a schedule or something.
Yeah, but yes, I think we'll be getting a schedule soon. We got it already.
Oh, you did?
Yeah, we got it.
Oh.
So math is Monday, Wednesday, Friday.
Okay.
Okay.
Do you know when
Math
English
is
is?
going to. What is that?
English? Do you know when English is?
I don't remember when English is, but then math is Monday, Wednesday, Friday, and I am thinking I will keep the same time. Are you guys okay with that, or do you guys having any conflict?
Pretty good.
We're okay with it.
Okay.
I think we're good.
Okay, so but it will be Monday, Wednesday, Friday starting next week. Okay, Monday, Wednesday, Friday, but I think I'm going to keep the 2 to 3 p.m. You have to remember to, in Google Classroom, please comment on the problems that you need to work with me every time you meet from the previous homework.
Wait,
Okay, so
so
Wait,
for for the homework, do we hold on to it or do we turn
Yeah.
it in?
I think I can give you guys an answer by Monday what to do with that, but until then, hold on to it.
Okay.
wait, Miss Mohandas?
Mm-hmm.
What are we gonna do about the benchmark?
I
Oh,
haven't heard anything from them. I don't think we will have the benchmark as assigned on April 3rd.
Oh,
We'll have to wait. They haven't said anything. Let's see when we are coming back.
wait, if it goes on till the end of the school year, will we just use the normal benchmark time? Benchmark like score?
If we go until the end of the semester, then I don't know how they're planning to give the benchmark. They probably won't give. We don't know.
so
Okay.
if we but if they don't give it, then would they just not count that towards the other stuff, or?
Yeah, Kalyan, I can't say anything about that because I haven't heard anything from them about the benchmark. Right now, everybody is kind of busy with how to deal with the classes.
Alright.
And then I think slowly, as we get close to the deadline of that benchmark, which is April 3rd, I think I will come to know something about that.
Okay.
Yeah, and as I get information, I will tell you guys when we meet, like what's going to happen. But as per now, I haven't heard anything about the benchmark.
Okay.
All right.
Yeah, so how are you guys doing?
Good.
Get
More.
enjoying? Huh?
Pretty boring. Been
Yeah.
playing Just Dance a lot.
Pretty boring because you guys can't go out.
Yeah.
Yeah.
Can't go anywhere.
If it is otherwise, it would have been okay, right?
Yeah.
Yeah. Yeah, I know. But then let's hope that we'll get out of the situation soon. And I really hope that it doesn't go all the way up to next fall.
Didn't the governor say that it was likely though?
Yeah, there's a
He said
possibility.
that
Yeah,
schools won't
Oh,
open
before we get-
until next academic year.
yeah,
Wait,
it is
all the way there? Oh my goodness.
Yeah. It's all the way to summer break, but hopefully that's not the case.
yeah, hopefully things improve really fast. Are you guys praying for it?
Yes.
Okay, sure. Okay. So then what else? You guys will ask me questions from chapter 8.1 when we meet Monday. And beforehand, let me know the questions in Google Classroom so I can be ready with that, because you know that we don't have too much time. And once a schedule comes up, I don't think we'll have this much time every meeting. They're going to restrict the time to accommodate all the teachers. So we have to maximize the time we are getting through this virtual learning. I want you guys to let me know the questions so I can be ready with the answers. So we'll quickly clarify the homework questions, move on to the next lesson. That's the plan.
Okay.
We are missing our warm-up and journal time.
Oh
Okay.
no.
Any other questions, anyone?
Do you know if we're gonna take the chapter 7 test anytime soon?
No, I have no idea. I will let you guys know as I come to know. Yeah.
Okay.
Yeah, but don't forget the stuff. Maybe Monday we will do a couple of problems from chapter 7 as warm-up.
Okay.
Okay, so keep refreshing. Don't forget, keep that in your head, okay?
Okay.
If we decide to come back on April 8th, then you probably have to take the test on April 9th, right?
Can you just give us all 100% on like that test?
Yes, please.
Okay. All right. We'll think about testing and later on as we teachers get more information from the admin or from the district. But otherwise, I think we are good for today's meeting. So
Okay.
can I end the meeting now then?
Yeah.
Sure.
Okay. All right, guys. I'll see you guys Monday from 2 to 3. Okay. Monday from 2 to 3.
Okay.
All
Okay.
right.
Bye.
Bye.
Thank you.
You're welcome. Bye.